Hello everyone and welcome to another video. Today we're going to be covering 8.2, converting complex numbers which are rectangular form to polar form, and we're going to cover 8.3, product and quotient theorem for complex numbers in polar form, and then we'll have one more video which will cover 8.4, powers and roots of complex numbers in polar form, and that will finish us out with Chapter 8, which will finish us all together with Unit 5. And then it'll be time for a Unit 5 test, and then after that, the final exam, and you are done with trig. Okay, so let's go ahead and get into it, because this can be a little bit long, more so in 8.3 than in 8.2. So you got several formulas you need to remember. First formula, x squared plus y squared equals r squared. That's your basic Pythagorean theorem, but we're talking about also the formula of a circle. We have y equals r sine theta, x is equal to r cosine theta, and tangent theta is y over x. These you already know. Conversion of x plus iy is going to be r cosine theta plus I r sine theta, which we convert down to r cosine theta plus I sine theta. And then we convert it down even more to make it simple, easy to write, r cis, which is cosine I sine, and then theta. So these are not very difficult problems, but they do take a little bit of time. First thing we need to realize is we need an x, a y, and an r in order to start this process. Okay, x is going to be the number or radical. So here's x. So x is going to equal the square root of 3. Y is going to be the coefficient in front of the I term. So in this case, y is going to be 1. Once I know this information, I can easily get r. So I have root 3 squared plus 1 squared equals r squared. Well, root 3 squared is 3, 1 squared is 1, equals r squared, 4 is r squared, so r is equal to 2. Okay, and from there, we need to also know theta. So right now we know r. I need to know theta, and we use the tangent theta. So tangent of theta has to equal y over x. Well, we know that y is 1, x is root 3. So tangent theta has to be 1 over the square root of 3. And this is positive 1 over positive square root of 3. So I look back, try to remember, where is tangent of theta, which is opposite over adjacent. Where is this? Put a square root of x when it should be square root 3. Okay, where does this angle, what is this angle that this relationship happens? We know that across from 1, theta is 30 degrees. So that means theta has to be 30 degrees. Now remember, you could have also done in your calculator tangent inverse 1 over square root 3, and that would have produced a 30-degree angle. Okay, so I now know that r is 2. I know that theta is 30 degrees. All I have to do is fill in this lovely formula here at the end. So 2 cosine I sine 30 degrees. And I have converted from rectangular to polar form. So moving to number 2, we need to know x, y, r, theta. Well, x is negative 2. Y is negative 2. Remember, x, and then the coefficient in front of I is our y. And I need to know r. So over here I've got negative 2 squared plus negative 2 squared equals r squared. So that's 4 plus 4 equals r squared. So 8 is equal to r squared. That means that r is equal to the square root of 8, which is, if we simplified, 2 square root of 2. I need to know my theta. So tangent theta has to equal negative 2 over negative 2, which is positive 1. So where is tangent theta equal to positive 1? The only place, well, not the only place, but the most easy place, 45 degrees. So we fill it in. R is 2 square root of 2 cosine I sine 45 degrees. All right, number 3. Number 3 is a little different. Got my x, got my y, got my r, need my theta. In this case, we have no x, therefore it is 0. Y is the number 3. And we need r. So 0 squared plus 3 squared equals r squared. Well, really quickly I can see that 3 squared is r squared, so r has to be 3. And now theta. So tangent of theta has to be 3 over 0, which is undefined. So where is tangent undefined? Where I get a number for y but 0 for x, that could be the quadrantal angle 90 degrees. Okay, fill in my information. 3 cosine I sine 90 degrees. Now, I know you're probably sitting there wondering right now, okay, well, this is really easy stuff, but how do I check my answer? How do I know that I got it right? Well, let me show you. So we need to get 3i. That's what we're trying to get. We said it was 3 cosine I sine 90 degrees. Well, let's work a little bit backwards. Remember that this is cosine of theta. This is I times sine of theta. So really this whole thing is 3 cosine of 90 degrees plus I times sine of 90 degrees. Okay. Well, what do I know about cosine of 90 degrees? It's 0. What do I know about sine of 90 degrees? It's 1. So really I have 3 times 0 plus 1i. Distribute my 3. 3 times 0 cancels out. 3 times 1i is 3i. So anytime you're not sure, you can expand it out to the cosine, the I sine, and then just evaluate. And you should get exactly what you started with. All right, well, number 4 is already in polar form. So we want to go from polar form to rectangular. So we're going to do just like what we did in that example. To check our answer for 3, we're going to do cosine of 120, sine of 120, and then distribute 2. So I'm going to do that up here. I'm going to go ahead and draw me a picture. because I always like to draw a picture just in case. Talking about 120 degrees, that's over here, which means that this is a reference angle of 60. So this is square root of 3, this is negative 1, this is 2. Cosine of 120 is negative 1 over 2. And sine of 120 degrees is square root of 3 over 2. Well, the great thing about this is that since this number matches my denominators, I can cross all the 2's off. That's going to give me negative 1 plus I square root of 3. Which is exactly why we are not going to work out this U-try problem right there. They are the same. So down here, this U-try problem is going to come out to be exactly what's here, 2 cosine I sine 120. Okay. Just to save us some time so you're not watching an hour-long video, which you might already be at this point. So, number 5 is 7 cosine I sine 180. So I need to convert to rectangular form. So we'll go ahead and expand. 7 times cosine of 180 degrees plus I times sine of 180 degrees. What do I know about cosine of 180? I know it's negative 1. What do I know about sine of 180 degrees? I know it's 0. So I really get just the number negative 7. Alright. You had a few U-try problems. Remember, we are not doing A, because we already did one just like it, but B, C, D, E, F, and G are for U-try. So pause the video, try to work through these problems, work through the formulas, and then come back. Alright, hopefully you pause the video at this point and have worked out these problems. First thing on this one is I'm going to distribute the 4. So I get negative 2 root 2 minus 2 root 2 I. And then I'm going to know that x is negative 2 root 2. Y is negative 2 root 2. And R is the number 4. Theta. So for theta, remember we have tangent of negative 2 root 2 over negative 2 root 2, which is going to give me, really I've got negative 1 over negative 1, which is going to produce the number 1. But since I'm talking about a negative y and a negative x, that's going to give me third quadrant. This is negative 1, this is negative 1. So that means this angle right here is what I'm looking for. That's 225 degrees. Okay. So that means that my answer is, I already know R is 4, so 4 cosine I sine of 225 degrees. Letter C, we know that x is equal to 5, y is equal to 0, that means R is equal to 5, and we need to know theta. Okay. Where we are talking about tangent of theta, talking about y over x, which means it's 0, and tangent is 0, at 0. So I'm looking for 5 cosine I sine of 0. I'm going to do E. So I'm going to need a little bit of room for these other ones. So I'm going to do E right now. X is -4, Y is 0, R is 4, and we need to know theta. We need to know tangent of 0 over -4. Okay, and you know when Y is 0 but X, the tangent with X is negative, that's going to be 180. So 4 cosine I sine 180. Alright. Now let me scroll down just a little bit. Because we still got D, F, and G to worry about. Alright. I'm going to go ahead and do F because that's another conversion one. These are just, D and G are just multiplications. So X on this one is 2, Y is -2 root 3, R is 4. So tangent of theta has to be -2 root 3 over 2, which is really -root 3. Well, where's tangent -root 3? 300 degrees. So I've got 4 cosine I sine of 300 degrees. Okay. For D, I think you can multiply and get all this out without me working through these. You're going to get -3 plus root 3 with an I. And for G, -3 root 3 over 2 minus 3 over 2i. Okay, on 6, 7, and 8, we actually have to use our calculator because the numbers don't work out. They're not nice reference angles. So here, for number 6, x is 3, y is 4, r is going to be 5. Because 3 squared plus 4 squared equals 5 squared. It's Pythagorean triple. And I need to know theta. Well, I need tangent of theta to be 4/3. That's not a reference angle that we know right off the top of our heads. So this is where you need to do theta is equal to tangent inverse of 4/3. That way you get the theta angle. Theta is going to be 53.13 degrees. So, writing out my answer, 5, that's my R, cosine I sine 53.13 degrees. Number 7, x is 5, y is -8, r is going to be the square root of 89. And I need theta. So tangent of theta has to equal -8/5. Yet again, not one that we know right off the top. So theta is the inverse of -8/5. And in this case, we get that theta is -58 degrees. Okay. So that means that my answer, square root 89 cosine I sine of -58 degrees. Last one, number 8. Remember these, when they're in this form, we expand. So 2 times cosine of 76 plus I sine of 76. Cosine of 76, sine of 76. This is not one that you readily know. So in my calculator, what I did 2 and then cosine 76. That gives me 0.483. And then 2 sine 76 was 1.941. And don't forget my letter I. It's a rectangular form. Okay. Remember, if you guys have any questions, to make sure to send me an email so we can talk about it. But we're going to go ahead right now and move on to 8.3. Product and quotient theorems for complex numbers in polar form. Okay, so what we've got going on here is that we're going to say that if P is R1 cosine I sine theta 1 and Q is R2 cosine I sine theta 2, then P times Q is R1 times R2 cosine I sine theta 1 plus theta 2. If we do, that's multiply. If we divide, then it's R1 divided by R2 cosine I sine theta 1 minus theta 2. Really what we're trying to say is that in case of number 1, if I have 5 cosine I sine 18, that's P. 4 cosine I sine 12, that's Q. If I multiply these two together, here's what I'm actually going to do. Five and 4, I'm going to multiply. 18 and 12, I'm going to add, and then write the answer. 5 times 4, that's 20. Cosine I sine 18 and 12, I add together, that's 30 degrees. Now, this is the simplified version of the multiplication. The answer must be in rectangular form, which means I've got to get this to rectangular, which is easy. We expand. Cosine 30 plus I times sine of 30. And I change them and multiply. What is cosine of 30 degrees? So just as a reference, here's our 30, 60, 90 triangle. Across from 30 is 1. Here's root 3. Here's 2. So cosine is square root 3 over 2. Plus I. Sine of 30 degrees we know is 1/2. Now I multiply and simplify. 20 multiplied by root 3 over 2, that's 10 square root of 3. 20 times 1/2 I is 10I. And there it is in rectangular form. So this is not meant to be difficult. It is just multiplying and using the formulas. Okay, number 2. We've got 3 multiplied by 5 and 120 plus 300. So that's 15 cosine I sine of 420 degrees. Which means we got 15 multiplied by cosine of 420 degrees plus I times sine of 420 degrees. Okay, reference picture. So we're talking about going around 360 and then going 60 more. So this is a 60-degree angle. So cosine of 420 degrees, which reference angle 60, is 1/2. Sine of 420 degrees is square root 3/2. Multiply the 15. So I got 15/2 plus 15 root 3/2 I. Okay. Number 3, you should try on your own. Okay, I'm giving you a few seconds. Hopefully you pause the video, try it on your own just to check yourself. Okay, so I've got 3 times 5 and 120 plus negative 60. So I have 15 cosine I sine 60 degrees, which means it has the same answer as number 2. Because 420 and 60 were the same angle. All right, number 4, 6 cosine I sine pi/4. That really means 6 cosine I sine pi/4 times 6 cosine I sine pi/4. So we multiply and add. So we've got 36 cosine I sine. Well, pi/4 plus pi/4 is 2 pi/4. And when we simplify that, that's pi/2. So I need to do 36 cosine pi/2 plus I sine pi/2. Remember that picture? We're talking about pi/2, which is right here, 0, 1. Well, cosine of pi/2, 0. Sine pi/2 is 1. So the answer is 36i. Okay, number 5. Now we're getting into the division ones. Division ones work. I'm going to do the same kind of thing. 16 and 8, these are divide. 15 and 30 are subtract. So I now have 2 cosine I sine of 120 degrees. Let's convert to rectangular form. So that's 2 times cosine of 120 degrees plus I sine of 120 degrees. Picture for reference. Here's 120 degrees, which is a reference angle of 60 degrees. So cosine of 120 is negative 1/2. Sine of 120 is root 3/2. 2 matches the denominator, so cross off all the 2's. And I'm left with negative 1 plus I root 3. I'm going to go ahead and do number 6. Remember, these 2 we're going to divide. The other 2 we subtract. So I have 1/2 cosine I sine of 45 degrees, which is 1/2 cosine of 45 degrees plus I sine 45 degrees. So picture for number 6, or 45. One square root of 2. So cosine of 45 and sine of 45, they have the same answer for 45-degree angles. It's 1 over root 2, or we say it's square root of 2 over 2. Multiply them. We get square root of 2 over 4 plus I square root of 2 over 4. All right, we're moving down into the U trisection. Now, the U trisection does not extend to part B here. It is just A, B, C, and D. So if you will, go ahead and work those out, and then I will provide you the answers. Hopefully you pause the video and are ready to see the answers. Here's what we got. For A, we get -6. And I'm going to go over these two. Now I'm going to show you about this one. C, we get -2I. And D, we get negative square root of 2 over 4 plus square root of 2 over 4I. All right, so those are A, C, and D. For B, what I've found is I went ahead and converted them. This is 2CIS -20. And this is -2CIS -100. And then I did our trick of multiply, add. So we've got -4CIS -120, which means we're talking about this angle here, which is a 60-degree angle, where it's -√3, -1, and 2. So I get -4 multiplied by cosine of -120, which is -1/2. Then I need sine of this, -120, which is going to be -√3 over 2. I. Now I distribute my -4. -4 times -1/2 is 2. -4 multiplied by here is going to be +2√3 I. Alright, for the last two problems for this video, and then we'll only have one more video, 8.4. So, right here, number 7, 2 plus 2I multiplied by 7 minus 7I. We know that from Algebra 2 that I can go ahead and multiply these. So I'm going to go ahead and do that. It doesn't tell me to do that up here, but I'm going to do it, and then I'm going to go through what they talk about to show you what they're trying to show you. Okay, so 2 multiplied by 7 and 2 multiplied by -7i. So that's 14 and -14i. Fix those, they look awful. And then 2i times 7 and 2i times -7i. That's going to give me a positive 14i and a negative 14i squared. Lots of 14s here. Well, these two in the middle cancel out. I've got 14, and I know that I squared is -1. So really, I've got 14 plus 14, which is 28. So that's simple. Very easy to do. I'm just going to write that up here just so we keep track of it. That's 28. What they want you to do is multiply the following by converting each of these to polar form, then product rule, then convert them back. So let's do it. Okay, for the first one, x is 2, y is 2, r, and we need theta. Well, if x and y are the same number, theta's got to be 45 degrees, or some variation. Okay. R, 2 squared plus 2 squared. We've done this one earlier. That's 2 square root of 2. So that's 4 plus 4 equals r squared. So r squared is 8. Square root of 8 is 2 square root of 2. So polar form for the first one is 2 square root of 2 cosine I sine of 45 degrees. All right, second one. X is 7. Y is negative 7. R and theta. Okay. Well, if y is negative and x is positive, that means we're talking about over here. So we're still talking about negative 1, right? Y over x. So this has got to be 315 degrees. R has got to be 49 and 49. So it's going to be 7 root 2. So I've got 7 root 2 cosine I sine of 315 degrees. Now we do our trick. Multiply these, add these. It's going to give me 14 square root of 4 cosine I sine of 360 degrees. And we know square root of 4 is really 2, so we're really talking about 28 cosine I sine of 360 degrees. Okay, so we've done the first part. We converted, then we used product. Now we've got to convert back. So 28 cosine of 360 plus I sine of 360. Well, remember when we're talking about this picture, we're talking about 1, 0. Cosine is 1, sine is 0. 28 times 1 is 28. And look, they matched. Now, I'm not entirely sure why we would go through all of this to get to this, and we can multiply it out, but I think the main purpose here is to see that you can represent mathematics in a variety of different ways. You can solve a problem using varieties of different techniques, and this is one of them. It is a longer technique than just multiplying, but it does demonstrate that there are 2 ways to do this problem. Okay, there is one more to do, and that is this problem here. So first one, x, y, r, theta, and the second one, x, y, r, theta. So first one, x is 1, y is root 3. That means r is 2. And theta would have to be square root 3 over 1, which is just square root of 3. That means it is a 60-degree angle. Second one, we have root 3 and negative 1. That would mean that r is still 2. And theta, well, we need negative 1 over root 3. So where is x going to be positive, but y is going to be negative? That's going to be it again right down here. X positive, y negative. So we got negative 1, we've got root 3 right here, and I need to know this theta. Well, that's some variation of 30 degrees. and it looks like it's going to be, I'm just going to use a negative angle. You could use 330, which is perfectly fine, but I'm going to use a negative angle. I'm going to say it's negative 30 degrees. Now I'm going to write it down that you could say, or it is 330 degrees. The reason I'm using negative 30 is I know that I'm going to add 60 in this angle. And instead of making 390 and have to go around and then up a little bit more, I can just say, well, 60 and negative 30 makes 30. Very easy to do, simple angle to work with instead of going all the way around the circle and then doing reference angle 30. So doing the conversion here, we've got 2 cosine I sine of 60. And then I have 2 cosine I sine of negative 30. So multiply, add, we get 4 cosine I sine of 30. And so, I'm talking about 30 degrees. 1, 2, root 3. Cosine is root 3 over 2. Sine of 30 is 1/2. Multiplying by 4, I get 2 square root of 3 plus 2i. Okay, so remember this for just a moment, 2 square root of 3 plus 2i, because I'm going to make all this disappear, and then I'm just going to multiply these together to see if we get the same answer. So 2 root 3 plus 2i. Okay, let's multiply these together. 1 times square root of 3. And then 1 times negative I is negative I. Square root 3i times square root of 3 is 3i. Square root 3i multiplied by the negative I is negative square root 3i squared. Well, I have square root of 3, so use that. Negative I plus 3i is 2 i's. And I know this is I squared, which is negative 1, so change that to a positive. I can combine the square root of 3's to get 2 square root of 3 plus 2i. They match. Okay, ladies and gentlemen, that is it for this video about converting rectangular to polar and then multiplying polars and converting those to rectangular. The only thing left is powers and roots of polar forms, and then we are done with the unit.